Example 2, find the asymptotes and symmetry of this function. Okay, so let's rewrite this as y is equal to, instead of tan, this is sine x over cos x. Okay, and cosecant would be 1 over sine x. So if I'm looking for the asymptotes, I'm really just looking for where the denominators are equal to 0 here, right? So this is going to happen in intervals of pi over 2 plus n pi. And sine x is going to be equal to 0 in intervals of just n pi. So if we put that together, right, if we say, well, it's just really going to be every pi over 2, like every 90 degrees all the way around, then this is just pi over 2 times n, where n is an element of the integers. Okay, and maybe we should have said vertical asymptotes at. All right, so there's our vertical asymptotes. And then let's figure out our symmetries. So we want to say, okay, what is f of negative x in this case? So this would be equal to tan negative x plus cosecant negative x. All right, so now let's think about that for a second with our unit circle. So these are angles, right, that we're talking about. So then whether or not we're going in the positive direction or in the negative direction. So let's just consider some angle, here. Well, then if we consider tan, we'll do that one first, right? So I'll just do tan and then I'll do cosecant. So tan is really sine x over cos x. All right, so in this quadrant, cos x is like my x, that's going to be this one, and this is my sine x up and down. So that's a positive over positive. So this is going to come out positive, right? So my answer in this case for tan x is going to be some positive number. Okay, if I went the other direction with like equal magnitude, like the same thing down this way, for sine x over cos x, then this time I've got negative, like a negative sine over a positive cos. So this is going to come out negative, right? So you can see tan in this case is going to come out positive, but it's going to be, of that number. And in this case, it's going to come out negative. So it looks to me like we could replace this tan negative x with negative tan x. It's the same thing, right? All right, so now let's do the same thing for cosecant. So with cosecant, let's say we had, so that's 1 over sine x. So in this case, that's going to be positive and if it's in quadrant 1. And if it was down in quadrant 2, well, now it's negative, right? The length here is on the other side of the x-axis, so it's negative. So it's like positive here, it's negative here. So this would also be negative cosecant x. And this pattern would be the same. Like maybe I'm just doing quadrant 1 and 4 every time, right? But it'd be the same if we had like an angle, let's say here, right? Or, so call that x. Actually, no, here, let's do this. It's really, let's say this was the angle and it was going down this way, right? Negative angle, we'll call that x. Well, that, if this then was, the opposite, like negative x, then our tan is going to be the same, right? Because we have, one positive and one negative on that, right? So it's always going to be the case that they'll be like the flip of each other. Okay, so there you go. So then from there, let's just do one last step. I'm just going to factor the negative out of this now. So we've got negative bracket tan x plus cosecant x. Okay, so this is the same thing as saying f of negative x is equal to negative f of x. Okay, so therefore we have an odd function. So say therefore odd symmetry.